Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-2 for October-November 2024, questions 1 to 4. Question 1 is coming from the basics of probability. They are saying that at a college, the students choose exactly one of tennis, hockey, or netball to play. The table shows the numbers of students in year 1 and year 2 at the college playing each of these sports. And we are given all of these here. Then we are told that one student is chosen at random from 120 students. Events X and N are defined as follows. X is for the student who is in year 1. N, the student plays netball. And then they are telling us to find probability of X given N. Probability of X given N, this is the same as probability of X intersection N out of probability of N. This is conditional probability. Now X intersection N, the student is in year 1 and plays netball. So in year 1 and plays netball, it is here. So I'll write 12 out of 120. Then I will divide by a student, the probability of a student who plays netball. So netball, I'll come here and I add these two, 12 and 28. We shall get 40. So it will be 40 out of 120. So this is the same as saying 12 out of 120 times 120 out of 40. So there is, since I've multiplied by the reciprocal and 120 is common, that one will go. And then we have 12 over 40. So by 4 in 12, we shall get a 3, and then by 4, 10. So this one will give us 0.3 or 3 over 10. Then part B, probability of N given X. This one is the same as N intersection X. Probability of N intersection X is the same as probability of X intersection N, and we have gotten it as 12 out of 120. Then probability of X, the student who is in year 1. So year 1, they are all of these. So 16 plus 22, that one will give us 38. 38 plus 12, that one will give us 50. So this will be 50 out of 120. So just like before, this is 12 out of 120 times 120 out of 50. This one will go. And then from there, 12 out of 50 by 2, we can get 6. Then by 2, 25. That one goes into 100 4 times, so it is 0.24. 0.24. Okay. Then part C, determine whether or not X and N are independent events. So we shall have probability of N intersection X, which we have gotten as 12 over 120. This one can even be 1 over 10. Okay. Then probability of X, we have seen it is 50 over 120, which I can write as 5 over 12. Probability of N is going to be equal to, we saw it here already, down here, which is 40 out of 120. It is 40 out of 120, which is actually a third. Okay. Now, for independent events, those are our values we have gotten from the table. For independent events, it is known that if I'm finding the intersection of this probability of N, intersection X is supposed to be probability of X times the probability of N. Okay. Now, what is the probability of x is 5 over 12. Then times the probability of n is a third. So this one will give me 5 over 36. So from the multiplication of these ones, I get this. Okay. But it is not the same as what we are having here, 1 over 10. So since it is not the same as that 1 over 10, then that means that the events are not independent. So I just say hence not independent. In other words, they are dependent. Independent events, the occurrence or non-occurrence of one of the events does not affect the occurrence or non-occurrence of the other. Okay, then next, one of the students who plays netball takes 8 shots at the goal. On each shot, the probability that she will succeed is 0.15 independently of all other shots. This one can be a geometric or a binomial, but this one is actually binomial because the number of times the experiment is done is known, 8 shots. Okay, so that is therefore a binomial, and the outcomes are independent of each other. Okay, so we are finding probability of x less than 3. So find the probability that she succeeds on fewer than 3 of the shots. Okay, and this one of course is going to be probability of x is equal to 0. Then probability of x is equal to 1 when there is 1 success. Then where there are 2 successes. Yes, I think we are ending there because it is less than 3, so we cannot put 3 there. So our p, first of all, is 0.15. That means our q will be 0.85. Now here we shall have 8 combination 0. Then the p is 0.15. So no success, it is power 0. That means the failures are the ones which are 8. Then 8 combination 1, 0.15 power 1, 0.85 power 7. Remember, when you add these powers, you should be in position to get your n, which is 8. Okay, so that is that. Then plus we have 8 combination 2, and then 0.15 power 2, then 0.85 power 6. So I'm going to put all of this in the calculator at once, and then we get the answer. 8 combination 0, actually that one is 1. Then 0.15 power 0 is also 1, so I'll have 0.85, and then power 8, then plus 8 combination 1 is 8 times 0.15, then times 0.85 power 7, then plus 8 combination 2, 8 combination 2, okay, 8 times 9, I mean 8 times 7, that is 56, so when you divide by 2, that be 57, okay, 8 combination 2, then times 0.15 power 2, then times 0.85 power 6, and then all together this one gives us 0.895 to 3 significant figures. 0.895 to 3 significant figures. That is that. Question 2 is coming from combinatorics, permutations and combinations. Part A, find the number of different arrangements of the 9 letters in the word algebraic. So the number of different arrangements, if these are 9 letters, then I'll write 9 factorial. But then I'll look out for the repeating letters. I can have an A and an A there. There are 2 A's, so I'll write 2 factorial. Then times. Is there any other that is repeating, there is actually no other. So that means it will just remain here as 2 factorial. Then when we put this one in the calculator, what we get? 9 factorial, we divide by 2 factorial. That one is 181,440. 181,440. Next, part B, find the number of different arrangements of the 9 letters in the word algebraic in which there are no more than 2 letters between the two A's. No more than 2 letters. This one means less than or equal. So we can have 2 letters, we can have 1 letter between the two A's, and then we can also have no letter between the two A's. Okay, so I can begin with no letter. No letter between the two A's. So I can have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can have an A here and an A here. That means the A's are going to be together. Okay. Now these we are left with how many letters? We have removed the 2, so we are left with 7. That means in here I will have 7 factorial. Okay. To arrange these other ones, I'll have 7 factorial. So that is 7 factorial. However, these 2 can shift. Okay. So here they are in that position. They can be here. That is the second one, third one, fourth, fifth, sixth, seventh, and then 8th. So those are 8 places where they can be. So I can multiply this one by 8 because it is still going to be the same thing. When they are here, we still have 7 factorial ways of arranging these others. Then let's go to the next. If we have 1 letter between the two A's. 1 letter between the two A's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have an A here and an A here. Okay. Still, to arrange the other remaining letters, it will be 7 factorial. But now this one, they can be here. Then again, they can shift. So this is 1, then 2, 3, 4, 5, 6, 7. Okay. So this one can happen 7 times. So I'll multiply this by 7. And then how about when we have 2 letters in between the two A's? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have an A and then an A here. Okay, again, the other letters will be arranged in 7 factorial ways. So this is 1. Okay, now shift it here. 2, 3, 4, 5, 6. Okay, so this will appear 6 times. So I will say times 6. So meaning our total number of arrangements is going to be that 7 factorial times the 8. Then we have 7 factorial times the 7. And then we can have 7 factorial times 6. In other words, this one can be given as 7 factorial is common. You can just have 7 factorial, then into 8 plus 7, which is 15, plus 6. Okay, so it is 7 factorial times 15 plus 6, isn't that 21? 21, and then the whole answer is both. So 7 factorial times 21. So our answer becomes 105,840. 105,840. 40. As simple as that. Question 3. A fair coin and an ordinary fair six-sided dice are thrown at the same time. The random variable x is defined as follows. If the coin shows a tail, x is twice the score on the die. If the coin shows a head, x is the score on the dice. If the score is even, x is 0 or otherwise. X is 0 otherwise. So what do they mean by this second statement here? They say that if the coin shows a head, x is the score on the dice. If the score is even, like 2, 4, 6. Okay? But then x is 0 otherwise if you get other numbers like maybe 1, 3, 5, like that. So on the sample space of the fair six-sided die, we have 1, 2, 3, 4. The scores, we have 1, 2, 3, 4, 5, and 6. Okay. Now, let's draw. Before we draw up the probability distribution table, we need to find out what we call the possibility diagram. So let us first consider possibility diagram. So if this is the dice, 1, 2, 3, 4, 5, 6, those are the outcomes. Then for the coin, I can have a head and then a tail. Okay, then I can put them in the table. So that is my table there. You can separate this one, and I say this is for the dice, and then this is the coin. They told us that if the coin shows a head, x is the score on the die if the score is even. Okay, and x is 0 otherwise. So the scores which are even, we can see 2, we can see 4, we can see 6. Okay, so that means we are going to write here a 2, a 4, and a 6. Then these others I will put a 0. Then if the coin shows a tail, x is twice the score on the die. So if this is 1, then times 2, you get 2. Then 2 times 2, you get 4. Then 3 times 2, you get 6. 4 times 2, you get 8. 5 times 2, you get 10. And then 6 times 2, you get 12. Okay, so that is what we are having there. Now next, we can draw our probability distribution table. Okay, and this is our table here. We have, first of all, x, and then the probability of x is equal to x. So the x values, we have 0, we have 2, we can see a 4, we can see a 6, we can see 8, we can see 10, and we can see 12. Okay, so in the table, this is what we have. So how many zeros do we see? 1, 2, 3. Okay, so this one will be 3 out of the 12. And then 2's, we can see 2, so 2 out of the 12. 4's, we can see 2 out of the 12. 6's, we can see 2 out of the 12. Then 8, it is just 1. 10, it is just 1. And then 12, it is just 1. Okay, so when you add these probabilities, we must be in position to get 1. 3 plus 2, 5 plus 2, 7 plus 2, 9, 10, 11, 12 out of 12, which is 1. So meaning our answers are correct. Then find the variance of x. Now for the variance, I need to have ex and ex squared. Okay, so I'm just going to get my table here, and then I shift it and put it here so that I can add on the other columns that I need. Then we need to add on x times the probability. So x times the probability of x is equal to x. Then another one is x squared times the probability of x is equal to x. Then I can complete my table here, just like that. And then we multiply 0 times this one here, we shall get a 0. And also here. Then 2 times 2 over 12, that one will give us a 24. No, it will give us a 4, sorry. This is 4 over 12. Okay. Square this one, you get 4. Times 2, you get 8. So this will be 8 over 12. Then 4 times 2, you will get 8 over 12. Then 4 squared, that is 16, times 2, 32. So right here, 32 over 12. And then 6 times 2, that one will give us 12 over 12. And then 6 squared, that is 36, times 2, that is 72. So 72 over 12. Then 8, of course, times 1, that will give us 8 over 12. And then 8 squared, 64, times 1, shall get 64 over 12. And then 10 times 1, that will give us 10 over 12. And then 10 squared, 100 times 1, that's 100. This one is giving us 100 over 12. And then 12 times 1 over 12, that will be 1 or 12 over 12. And then 12 squared, that is 144 times 1, that is 144 over 12. Now what is EX here? It is the summation of everything that we are having here. Okay, so we have 4 plus 8, that is 12, plus 12. That one is 24, plus 8, 32, plus 10, that is 42. Then plus 12, that one will give us 54. So this is 54 over 12. How about here? 8 plus 32, that is 40. Okay, 40 plus 100, that is 140. Then plus 144, that is 284. Okay, then plus the 64 and 72. So altogether, this one will give me 420. So this is EX squared, which is 420 divided by 12. So for us to get the variance is equal to 420 divided by the 12. Then subtract 54 over 12, but squared. It's the difference between the squared means. So we have EX, then minus E of X, then squared. So when we put everything in the calculator here, what do we get? 420 out of 12, then minus 54 out of 12 squared. This one is 59 over 4, which is the same as 14.75. 14.75. That is that. Number 4, the heights in meters of white pine trees are normally distributed with mean 19.8 and standard deviation 2.4. In a certain forest, there are 450 white pine trees. How many of these pine trees would you expect to have a height less than 18.2? So here I need to first find a probability, then after I multiply by 450. So the mean is given as 19.8. Standard deviation is given as 2.4. So we need to find a probability of X, which is less than 18.2. And then we standardize this probability of Z, then less than, remember, the Z is equal to X minus mean out of the standard deviation. So we shall have 18.2 minus the mean, which is 19.8, out of the standard deviation, which is 2.4. Okay, then what do we have here? We can first simplify that. What do we get? We have 18.2 minus 19.8, then we divide by 2.4. So it is negative 2 over 3. Negative 2 over 3. So on my bellow-shaped curve, The negative is this side, so negative 2/3, and they want less than. This is the one here, okay? But this one is actually the same as greater than the positive, okay? It is the same as this one here. So to get this one, you will say 1 minus the one for the less than, okay? Z less than the 2/3, 1 less than this. I mean 1 minus the probability of Z less than all of that. Now, this one here is actually, that's why you find in the normal distribution they have put, in fact, they put probability of the negative Z, okay? In fact, they don't use probability, they write phi of negative Z is equal to 1 minus the phi of the positive Z. It comes from here, that the less than of the negative is going to be the same as the greater than of the positive, and phi of Z is probability of Z less than that given value of Z, okay? So that is that there. Now, but else we can use a calculator straight away and you get those answers, okay? So let's use the calculator and you see what we get. If start is not on your calculator, you go and press mod, then start is 3, then you press SC when you see this on the screen. Then from there you can have, these are the same functions if you have a calculator FX991ES, okay? You will still be getting the same thing as I press here. Then you press shift, then you come to button 1 which has start, and then you choose distribution, which is 5. 1 is for the less than, that P is for the less than, 3 is for the greater than, okay? So we have 1, and then I can just put negative 2 out of 3 the way it is. This one can give you the values for the negatives also. So that is 0.25249. 0.25249. Then from there, the expected number of trees, I'll just say E of X is equal to 450 is going to be NP, okay? NP, then you have the 450 times the probability you have gotten, 0.25249. Then what do we get? So the answer I have here, I'll just multiply it by 450. Then I get 113.6205, 113.6205. So that means I can take 113 trees, okay? You cannot have 0.6205 of a tree, or you can say 114 trees. So any of these you put, they give you, but in the exam don't say 113 or 114. No, write 1. All are correct. Then they are saying here the heights in meters of red pine trees are normally distributed with mean 23.4 and standard deviation sigma. It is known that 26% of the red pine trees have height greater than 25.5 meters. And we are told to find the value of that sigma, or the standard deviation. Now, we are having probability of X greater than 25.5. The probability is actually given as 26.6, but I need to standardize this. I will have probability of Z greater than the Z1, okay, which is equal to that 26%, and it is going to be 0.26. Now, that is 0.26. I need to do 2 sketches like in the previous papers. I've been showing you how to get the Z value, whether it is positive or negative, because it is possible for it to be a negative or a positive. So when you sketch those two, put Z on the left, it will be a negative. You can also put Z on the right. Why am I saying left, right? Of the mean of the standardized normal distribution is the 0. Now they want greater than. So you look at the right of your Z value that you have put there. So also the right here. Then you ask yourself, which of these two represents the probability, which is 0.26? Remember, when you draw this normal distribution curve, this is 0.5 this way, and this is also 0.5 this way, you see? But now, when we go to the right of this one here, the first one here, this one is going to be bigger than 0.5 because already inside here it is 0.5. That means you are adding something here. You see that? So it is going to be greater than 0.5. So it cannot give you the 0.26. You see that? So that means the one that is going to give us is the second one here. This one can be a 0.26 because it is below the 0.5, because the whole of this is 0.5. So therefore I'll take my second one here. Okay, so Z is therefore going to be a positive. And then we get the phi inverse of this 0.26. So which Z value is giving us the probability as 0.26? So I'll go to the normal distribution table, and then I look out for that 0.26. But you realize that the table they give you, because it is for the sketch, this one here, for the less than, the whole of this one is way bigger than 0.5. Okay, so that means you cannot get probabilities which are below 0.5. So therefore, what do? We are supposed to instead use the other part, because Z is just a boundary. Okay, so I will instead look out for the Z value that corresponds to the other probability, 1 minus the 0.26, which is 0.74. So 0.74. So I'll look out for this one. Okay, let's go now to the normal distribution table so that we get the Z value. So this is the normal distribution table, which is given in the list of family. So we are looking for 0.74. 0.74. You can see something here. 0.7389. So 74 is expected to be here. 0.74, because this one is 0.7422. It's already beyond. So I'll pick this value here, 0.6. Then I'll come here and I pick this one, a4. Then there is something that they added onto this 0.7389 to get the 0.74. So we find it out. We shall get 0.7400. Then we subtract 0.7389. And then this one will give us 11 here. And then 0.0. Now we look out for 11. So we go this other side. We look out for 11. But now 11 is not there. But we can see a 10 which is nearer to that 11. And then we can take this value here, which is a 3. So meaning our Z is going to be 0.64, then that 3 we have gotten here. So that is what we take the other side. Our Z value is 0.643. Remember, Z is equal to x minus mean over the standard deviation. So we shall have 0.643, which is equal to our x is 25.5, then minus the mean, which is given as 23.4, then over the standard deviation. So when I cross multiply, it means that the standard deviation is going to be that 25.5 minus the 23.4. Then we divide by the 0.643. Okay. Then to three significant figures, what will be my value of the standard deviation? We have 25.5 minus 23.4, then divide by 0.643. And this one is 3.27 to three significant figures. 3.27. So that is that. So this has been the first part of this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, Kindly like, share, and even subscribe. See you in the next videos.